Hello and welcome to another video. Today I'm going to be showing you how merge sort works. Merge sort is one of the faster sorting algorithms. It will be the fastest one that we would have looked at when this is done. It's a bit more complicated, which is why I have left it to last. So basically, if we have some boxes, the way it sorts them is it will first split the boxes up into multiple lists. So we're going to split these up. And then it's going to sort each list individually. So the first 1, 2, 3 and 77, and 2 is the right way around. And then from onwards, it will look at the first of each item, and then it will sort them together, and then it will sort these together. Now this formula or algorithm does use recursion. I went over recursion yesterday in the video called Towers of Hanoi. I did that in both Python and C. So you may want to watch that if you don't already know what recursion is. So let's get started. Something we're going to need is we're going to need a list of data. I am one step ahead of you and I have already made a 1,000-digit array, 100-digit array. Can't quite remember the size. If you want to copy and paste this array, it will be in the code, which will be linked in the description like it always is, as well as the link to the Discord, etc, etc. So the first thing we're going to do is we're going to make ourselves a function, and we're going to call this merge sort, because that makes sense, and we're going to pass in an array. So I'm just going to call this R. And then the next thing we're going to do is we want to check that our array is bigger than 1. If it's smaller than 1, it's a bit pointless solving, so just a quick check we have to do. The next thing we're going to do is we're going to find the midpoint. And because we're going to split our list in half, the thing here is we don't want any decimal points. So what we're going to do is do floor division. So mid is going to be equal to len, and then I've called our thing that we're passing through R for our array. It can be called whatever you want. And then for floor division in Python, it is /. Most other languages, it's not this, because in a lot of other languages, 2 slashes are comments. And now we're going to define left and right. So we're going to do left is equal to array. And then we're going to open some square brackets. We're going to put a colon, there we go, and write mid. So what this means is the colon is kind of get everything before. So we want to get everything before mid. And then we're going to do right, and right is equal to array, brackets, mid, and colon, which is everything from the midpoint onwards. And now we're going to want to run some recursion, and we're going to want to run this twice. We would want to then merge sort our 2 new lists, so we're going to want to merge sort left, and we're going to want to merge sort right. So there we go. Now we're going to create ourselves a few pointers, and these pointers will be used in a few while loops. So I'm just going to call mine I, J, and K. You can name them whatever you want. It's just when you do for loops, you always seem to use I, and then I always seem to use J, and K was just a letter that has been plucked. So this next bit's a bit complicated, so I'm going to do my code, and then I'm going to try and explain it. We're going to see how this works. So what we're going to first want to do is we want to create our while loop. So while position I is within left, or len brackets left. I don't know why I added that comma there, wasn't on purpose. And then we want to do the same for j, and j is less than len right. So what this is going to do is it's going to simultaneously go through our left side of our list and our right side of the list. And we're going to make sure that neither of our letters hit the maximum or get greater than the maximum amount, because you can't increase above the maximum. now what we're going to do is we're going to check the order of our points. And the way we're going to check if they're in the right order is we're going to do if left, and then we're going to open up some square brackets, I is less than right, and then some square brackets j. We are going to want to swap their place. And the way we're going to do this is... No, this means it's the right way round, which is perfect. So the way we want to do that is r, and then we want to find our k value, and then we're going to want to make that equal to left I. It's hard to write and talk, and then we are going to increase I by 1. And then we will do an else statement, and our else statement is basically the opposite, which means array, or r in our case, k, will be equal to right, and that will be position j. And then we're going to do j is plus equal to 1. And here where I wrote I is plus equal to I, that should be plus equal to 1 as well. And I have missed my colon at the end of else. And then we're going to, underneath our if statements, we're going to do k is plus equal to 1. So this isn't the full section of code, it's just a section, but we're going to try and explain this now. So once we've got ourselves our little list, so once it's been split up, we're going to want to loop through our left side of the list and our right side of the list. If our left side, so if our first item is less than our second item, it's in the right order. And in that case, we want to tell our main array that our first item, in our case, is equal to our left value, or that is the value we want to store there. However, if it is an else statement, it means the right value, so let's say our second value, is smaller than our first value. So what we're going to want to do is we're going to want to swap the values around, and then we're going to want to increase the pointer, or our location, by 1. And at the end of each cycle of the loop, let's say, so in our while loop, we want to increase the point we're looking at by 1. Because we've saved our first value, and we don't want to overwrite our first value the next time we do our checks. So by increasing it by 1, we move on to the second point, and then we'll loop it again, and then k is plus equal to 1. So we'll move on to the third point, and so on and so on. Because it looks a bit confusing, and you could change this, but k is our point in our array. So let's actually change. Let's make this clearer, and let's change point. So let's go Control H, K, and we're going to replace this to point underscore array. Find and replace. If you didn't know how to do that, it is Control H to do find and replace. There we go, and that should make it a bit clearer. So after this if statement, we need to continue merging our left and our right sides together, because we've split it, and because of recursion, we then kind of have to merge it back down. If we go back to our slide, and let's say we had a few more squares. Here we go. Let's copy and paste a few more squares. Don't mind the numbers. We split it out into our sections, like so, and then as we solve it, so we kind of then do the opposite, where we solve it in chunks, if that makes sense. So then you kind of break it down until you've got back to one big list. Just kind of came to me that what I was explaining might not be the clearest, so I've quickly got myself an image from Wikipedia. So we split it out, and then we start solving it, and we solve it into smaller lists, and then we start to join these smaller lists together. So that is what our next function, or our next section of that code will be. So here we go. So we're going to create ourselves a new while loop. And this is while I is then, again, less than len left. So when we use I, it will generally always be in regards to left here. And when we use J, it will always be in regards to right. I is position in left, and J is position in right. So there we go. We're going to put ourselves down as semicolon, and we're going to do array, and open up our square brackets k. So but we don't have k anymore. We changed that so to our point in our array is equal to left brackets I, and then we're going to want to do I is plus equal to 1, and k, nope, point in our array is plus equal to 1. I wrote this all out a minute ago just to make sure it worked, and then also redid it for school a few weeks ago, and both of those examples I did k, because we're always trying to use smallest variables possible in class for some reason. And now that's just ingrained into my head, but it's called point array. That's what we're working with. So why we've done that for, because we've done that for left, we have to do the same for right, because what we do for one, we do with the other. So like J is less than len right, we are going to then want to do array, and then point array is equal to right J, and then we want to do the same as above, so J is plus equal to 1 and K is plus equal to 1, and then we're going to want to return our array. And if you don't remember, we got this really big if statement here at the top, so we want to do else, and then we're going to want to return array as well. There, that was supposed to be return array. And I'm going to quickly explain what this last if statement did. So if we look back at, let's move this here, back at our earlier example. Where did that 2 come from? Oh well. We had an odd number of cards, which means when we were splitting them up into their sections, we did those 2 went together, these 2 went together, and then we had 77 on its own. So this big if statement, if it's less than 1, we don't need to sort it, because it being its only card means it is both the biggest card and the smallest card, so it's in the right place. So we can just return that point. We can just return it as it is. So what we're kind of doing here is we're sorting both sections, and then we're trying to join them together. And then we return it, so it goes back into our original function. Because if you remember, this is a recursive function. It calls itself, it then solves itself, and hands it back to its old self. Which is a weird way to think about it. So once it's been broken down fully, if it can't be broken down anymore, stop trying to break it down, and then you start trying to go backwards and solve it, or join it together. So that's what this if statement does. So now let's run it. We've written the code, we might as well see if it works. So we're going to print, merge sort, and we're going to pass in our array, which is called diglist. There we go, and we're going to hand that in there. Control F5 to run it. And we have an error, which is cannot unpack non-integer objects. So let's see, what is our problem here? And the problem here is where we've done our 3 variables. I've set them all to be equal to 0, but I haven't, because basically you have to type in a 0 for each variable you have, which is a weird thing to think about, and that does sometimes confuse me. And at the end, we wrote k, not point array. So there we go. That's the two things to fix. You need to have your three objects. Also, I, j point array is equal to 0, 0, and 0. And you need to make sure that when we change from k to point array, you change them all. So now let's give that a run. And as you can see by looking at this, it is in the right order. I mean, I used a massive list because I like bigger lists and it can help. The list gets big. You can kind of see the efficiency compared to the other algorithms. But to make this easier to read, we can just do ourselves a test array. And let's hand in 4, 99, 5, 2, and 1, 3. And we'll quickly run this with our test array. There we go. And then as you can see, that's a bit easier to check it works. So thank you for watching. I hope you enjoyed this video. I hope you learned something. Please consider liking, subscribing. The code, if you need it, is on the GitHub, which is in the comments and in the description, and the link to the Discord server is in the description if you need help or questions. So thank you. See ya.